Alrighty. Welcome to week 2 of CIT 225 in the fall. It's fall, yeah. It's weird to think that this is fall because I live in Florida where it's like 90 degrees outside and it's not cooling down at all. Brian, where are you from? Were you in Idaho or Utah or
I'm from DC, but I'm living in Rexburg right now.
okay. Oh yeah. So it's what, like 30 degrees out there right now?
It's like 60. It's
Yeah.
pretty nice out right now.
I see my daughter graduated from there, so I joke that it's always very cold out there. You have like 15 minutes of summer. All right, let me share my screen here. All right. All right. So we are in week 2. So let's talk about what's going on here. So tonight I'm going to talk about the mechanics of SQL. We're going to talk about some of these clauses and how basic. We're going to talk about how basic queries are written and how they work. We're going to talk about how the engine sees them. We're going to talk about why I call SQL an engine and a platform as opposed to an application. And then we're going to end up talking about this reverse engineering a website and how very, very, very simple this is, and it's nothing to panic about. And for those who watch the video and read the announcements, you'll do a great job on it. For those of you who don't, who will never hear what I say because you never watch the video and never read the announcements, you're going to be completely lost because you're going to get terrified when you see this. Okay, so, and I say that knowing that they're not going to hear me. Okay, so let's talk about SQL queries. Boom. So here we are. The very, very cool thing about writing queries in SQL Server, in T-SQL, is that it's like normal English. It's like you say what you want it to have done. It's not like C++ or VB.NET or C# anything like that asks you to like say weird things in weird ways with commas and colons and things like that. And it's just actual legit words, right? So the first word we learn is use. And every time you start writing queries, the first thing is you tell it what to use. Where are my schemas? Where are my schemas go? Oh, hang on a second. New query tab, and then why am I? Hang on a second. That's there we are. That's what it was. Okay, go away. Okay, here we are. And let me open up my thing here because it didn't open the way. So here, open with the notepad. Okay, here's what I want. Copy. Sorry about that. Momentary delay. So the first thing we do is we use use. Use tells us which database to use. Now, over here, I've got schemas. I've got Sakilla, I've got sys, and I've got world. My use command tells this which one of these to use. If I don't have that there and I don't run it first, it's not going to know which one of these to use. So simple, use. Use what schema I want. Every command ends with a semicolon. Simple stuff. Now, first query here, very, very simple. Select. Select tells the query what you want to see, what columns you want to see from the table. From tells you what table to use. So select from. It's pretty cut and dry, pretty simple, right? So here I'm going to say select last name, select first name from customer. And when I run this, I didn't use my use command first. I get my results. Okay. If I look over here on customer on my table over here, these are all the columns that exist in there. So I can ask to see any of these columns over here. Let's get a little more advanced. The next query here. Here's my select statement. Select, I'm telling you what to have. Here's last name and here's first name again, but I've done something a little different here. So when I ran it, select last name, first name from customer, I get this. I get last name as a column, I get first name as a column. Because this comma says grab this column and this column, because I need to use the actual names of the columns, because if I don't, it's not going to know what I'm asking it for. So if we look under customer, I've got a first name and a last name. If I want to add email address to that, I put a comma here and check this fun thing out. I can just do this. What? I want to do email. Let's drag it over. Okay. And now when I run it, I've got 3 columns. Okay. Now here, this looks a little different. Because I've got this weird word concat in front of it, and then I've got parentheses and this. So basically, so a lot of times when I'm teaching these queries, I do things in a natural way that makes sense. And this is something we're going to talk about for actually in the book for a couple weeks. So this is like week 4 or 5 stuff that I'm talking about here, right? So there's a way to manipulate the data, and we're all about manipulating the data to make it look better. Because if I give this to a customer, it's clunky. They're not going to like it so much. You know, it's kind of things, but I want to make it look nicer. So here I can say select, and concat is short for concatenation. Concatenation is a word that says take 2 strings and put them together into one thing. Okay, so here I'm saying concat, which is saying anything in these parentheses turn into one string, right? So I'm going to say get the last name, put in a comma in parentheses, in quotes, and then first name. So what's going to happen? I'm going to comment this out here real quick. Okay. So what's going to happen when I run this? I'm going to run both of these, right? The first one, where's it should have given me, okay. So run the first one again. We've seen that if I run this one, oh, if I run this one, I now have first name. I went to this. I went to there. If I run this one, I now have in one column the first name, last name, like you'd see normally, right? Not in 2 columns, in 1 column. But I've got this weird thing here. I've got this nonsense that no one's going to understand what that is, right? Because when I run a query and I use multiple columns to get what's called a configured result, it's going to call it whatever made it. So it's whatever created it. So instead of having this nonsense here, I can use this clause here. It's the as clause, and I can give it a name. So here I can do this. And now the column name is customer, and I have everyone's name in one column in a way that's easier for people to recognize. Okay. And when I do this, it doesn't have any particular order, right? So I can add, yeah, Ryan, what's up? You don't need to raise your hands, just you and me. You can just ask questions.
Okay. So obviously you use the alias customer, which is the same as the table name
Yeah,
customer.
yeah.
When you use the clause order by, your the customer in that sense is the table name and not the alias. Is that correct?
No, it'll be the alias.
Okay, okay.
Yeah, yeah. Because so SQL, and you bring up a good point. This is a bad choice too because it is matching. But when you put it in this context here, right, in front of this command or in front of this command, it knows you're looking for a column and not a table. So it's not going to think you mean the table. So I should do this, and I'll just, and it's less a confusion thing, right? So I'll do customer name. But yeah, so the SQL engine is smart enough to know that you're looking for a column and not a table. So but that's a great catch there. So here, if I run this, I have my order by, and it's going to put it in the order of last name. Now, what the order by clause does, it automatically does a descending order by. Did I get that right? Did I get it right? No, sorry. It automatically does an ascending, so it always does A through Z, right? If I want to do it backwards, I can change this to descending, DESC. And then I'll go Z to A. Okay. So again, like I said, it's almost like common sense coding, right? So here in this next query, Oops. Keep this going here. Next question here. All I've done is I've added store ID to the query. So now instead of just getting this one, instead of getting this where it's just the one result, I'm adding store ID. So I want to know what store this customer shops at, what the store ID is, right? But here, instead of ordering by customer name, which is this, I'm aliasing it, so it's going to order by this. I'm just going to order it by first name. Okay. So when I run this, it runs fine. But now we're ordering by first name. So I don't have to use the name of the concatenated column. I can use the individual parts of the column to organize as well. And there's my store ID. Now here, and you can tell I'm just building on the query with a new thing every time, right? So now I've got my select store ID, my concatenation of last name, first name, with my alias with as customer from the customer table. But now I've got order by store ID, last name descending. So now what I'm saying is when you order this, order it by the store ID and then order it by the last name going from Z to A. And when I run that, that's exactly what it does. So I've got all my store IDs and then they're ordered. So when I go here where they break up, I go from Avenue back to Ye. Now, the other thing I can do that I think is silly is I can do this. And if I run this, if I did this right, oh, this isn't going to work. So I got to do this differently. Okay, because let me do this real quick. Let me change this to let me get this new one here. Hang on a second. Okay, so what I'm trying to do here is I'm going to make this change here. Okay. So if I run this, I've taken away the concat, it's just store ID, last name, and first name. So I'm going to do this. All right. And now it's the same thing I've got just in 3 columns again, right? Now I was trying to show you is this. Now, what I did was, now here I said store ID and last name, right? Told what column I'm going to do there. Here I just use numbers. So what you can do, which I think is ridiculous, is instead of putting the names of the columns you want, you can put what order they're in here. So 1 and 3 is store ID and the first name. Why would you do this? I have yet to figure it out. I've been doing T-SQL code for 22 years. I've never done it this way. But there is a question on your quiz about this specific way of doing things. I think in your exercises as well. Next, I've got my select statement. I'm getting my select store ID. I'm getting my concatenation of first name and last name as customer. I'm getting it from the customer table. I'm ordering it by store ID last name. But now I've added a where clause. So the select clause tells me what columns it wants to see. The from clause tells me what table it comes from. The order by clause tells me what order to put the stuff in. And the where by clause filters the results to what I want to see. So now here, this query brought me everything back. This is going to be where the last name is Miller. And there's only one of those. Okay. 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 So now my where clause suddenly starts filtering the results. So whatever is in the where clause, it's now going to be a filter. I don't know why this one is here, but now the where clauses, I'm going to take this one. I'm going to move it down to the bottom because I want this one to be the last one we talk about because this can get a little, I'll put that one there. That, I'll keep that one there. That's fine. Let's move this one to here. That's fine. Okay. So now I have where last name is equal to Miller, which means it will show me anytime the last name is Miller. But what if there was more than one last name that I want to do? What if there was Miller and Smith? So here I can take the where clause, and instead of having an equal, I can have an in clause. And in that they're in, I can put multiple values of what value I want to see. So if I run this, it's going to show me all the Millers and all the Smiths, which there's 2 of them, right? So again, my where clause can use in modifier to give a series of specific values to look for. Now, because everything has its opposite, I can put the word not in front of this. And now the opposite's going to happen. When I run this query, it's going to show me everything from customers where the last name is not one of these 2. And now I'm going to have a whole lot more results. Okay. You follow me, Ryan? All right. All right, Brian, keep in mind you're speaking for the entire class. So no pressure. Now, here's another fun trick. I have the same stuff we've been talking about from customer, where last name, and I've got the in part, but now all of a sudden I've gotten tricky and I've put a query in that in clause. So this is what's called a nested query. Instead of having a specific static value, and these are static values, I have a dynamic value, which means this is getting more this way. And notice what I'm doing here, last name, and then I've got the query where select last name from actor, different table, where last name is Miller or Smith. Okay. So the where clause is going to run this query and then do this. So I'm going to do this, and it's going to be the same thing. It's going to be this. It's what was my error? There is no. Oh, do I not have? Ah, what is my error here? Select last name. Where's my error? Okay, so what is my error here? Let me troubleshoot this. So I don't usually mind having errors in the class because I want you to look at when you're writing your own code, you're going to have errors, but you have to look at, the error code. You have a SQL error in your SQL syntax, check the manual or corresponds to MySQL version. So that's telling me that I have an error with this. So it's telling me there's something wrong with this. So I'm going to take this and put it aside, bring it down here, and see if that runs on its own. That's not running. So it's running 0. It's returning 0 rows. And that's not what I want. I want to run okay. So let me put this here and make that slight change. Okay. So that was returning 0 rows, which made no sense. So what I've done here is I've done this a little different. I'm kind of jumping the gun here for the next one. But let's look at this one really quick. Select store ID, last name, first name from as customer, from customer, order by last name. But now I have where last name, and instead of like in or not in or equal or not equal, I just have like D %. So what this is going to do is going to return every customer that has a last name that starts with the letter D. Okay. Now I can play with this a little bit. I can take this %. So the % is the wild card. Okay. So basically what it says, I just wanted to start with D and I don't care what's after it. If it's a D in the start, it can have 10,000 letters after it. That's what I want to see. I can take this % and put it in front. Now it's going to say, show me every name that has a D at the end. And I run this, and all my last names will all have a D at the end. Okay. Now I can also do this. Show me a last name that's got a D somewhere in it. And I run it. And now somewhere there's a D at the end, there's a D in the middle, there's a D at the start. As long as there's a D in there, I just want to see it, right? And because we can be absolutely ridiculous, I can do this. What this does is it says, show me every last name where D is the first letter. I don't care what the second letter is. Okay. The third letter is A and then have anything after it at that point. So all I want is a last name that starts with D. I don't care what the second letter is. The third letter is A and then anything that follows. And if I run that, I get these two results. So the percent sign says whatever follows, follows. And whatever's before is before. I don't care what's there. This is, I want only one letter between the D and the A. If I do 2 spaces, it's 2 letters, or 2 underscores, it's 2, right? So on and so forth. Making sense? We good? Now back up to here. Oh, it's real quick. So again, I can put not in front of it and then get everything that's not like that, which is everything else. Okay. Looking back to here with my subquery, I'm now saying, show me store and last, show a customer name. Show me as customer name from customer, where the last name is in select last name from actor or last name like M. So it'll run this query first to get the results and then put it in here. So if I run this, why am I getting 0 results returned? Oh, I know why. I know why. Because there's no last names that match. So here, I'm getting this whole series of last names, right? And none of these are actually in the customer table. Let's try A. Yes, there we go. There you go. So in here, I get all this. I get this giant string returned of all these names: Aykroyd, Allen, and Astaire, and there is an Allen that shares between the two. Okay. If I put not in, I get everything else. Okay. Now, you still good with me, Ryan? Still going? All right. So let's build on that. Here I'm changing to the film table. I'm saying select title and description from film. Then I've got where description like, and I want that series of letters there. And then I've got the word or here, or the description is like this. So what this is going to do, it's going to show me everywhere the description has this in it, or it has this in it. As long as it's one of the two, it's going to be good. And I'll run it, and this is what I get. So everything's a documentary. Where's the OC in here? Oh, because this one has cow. This one's got cow. This one's got documentary and cow. Okay. I love these descriptions. A fanciful documentary of a frisbee and a lumberjack who must chase a monkey in a shark tank. I would probably watch that movie. It's probably on Amazon. A brilliant panorama of a mad scientist and a mad cow who must meet a pioneer in a monastery. So now here, I make one word chain. I have and. Or means satisfy either. And means you must satisfy both. So with this one, I had 37 results. I think 37 results. No, how many results did I have? Oh, it's down here. I had 167 results. So let me do the and.
Are you going to get the same results if you use in instead of or? Not in
Yeah.
replace of it, but use an in clause instead of like there and just do a comma instead of or? Is that going to give you the same results?
No, in is not going to work here
It's not going
because
to work.
no, because in says I have something very specific I want this to be. Like says I want it to be like this.
Okay.
Because I'm using these percent signs, I'm saying I've got variables. I want this to be similar to this. If I use in or equal, it says I want them to be exactly this. Because if I did this, if I put in here, I'm going to get an error because then automatically I need this. Right? Because in means I'm going to put an array past it.
Mm-hmm.
But if I do this, it's going to look specifically for this. It's going to look for percent, docu percent. If that doesn't
Okay.
show up, it's not going to do it. That's why I have to do like. And there's no like in. You can't do like in parentheses and have all the things show up. It doesn't work that way. Z. Okay. So again, I changed the orange to change an and, which means instead of either, both must be. So instead of 167 results, I get 93 results. And in this, there's documentary, and somewhere in here, there's cow. Because it's got to be both of them. Oh, and not like. Oh, in this case, it's document and not like cow. So I can have documentary, but I can't have cow. So I've got nothing here. So if I do like cow, I go from 93 results to 8 results. And it's just all about documentaries of cows. All mad cows. Oh. Already talked about that one. Okay. So now everything goes. So here's the same thing. Select store ID, customer, from customer, we're last name like D, and order by 1 and 2. So it's just, we talked about the 1 and 2 thing already, right? So what I'm about to talk about now is an advanced theory from like week 6, but it makes sense to talk about it now because I'm going to say something right now, and it's something I'm going to say over and over again because it's a very important principle of query rating that it takes a while to understand. So here I had these concatenations, right? So when I say concatenation, I'm talking about taking 2 strings and putting them to 1 string. So whenever you hear me the word say concatenation, I'm taking 2 things and making them into 1 thing. If I had a cookie and another cookie and some cream filling, I can concatenate an Oreo cookie. Okay? Because it's 3 individual things coming together as 1 thing. Okay? Now, the opposite of concatenation is aggregation. Aggregates. Okay? Aggregates mean I'm going to take the values and combine them into one, not making many, like 3 different things, one thing. I'm going to add them together. It's a math function. Concatenation only works with strings. Aggregates only work with numbers. So if I'm aggregating, if I'm concatenating 1, 2, and 3, I get 123. If I'm aggregating 1, 2, and 3, I get 6. Does that make sense? Okay. So here I'm doing aggregate functions. I'm doing aggregate functions. And there's several. We're going to talk, there's a couple I'm going to show you here. There's way more than what we're going to talk here. The first one is count. What this is basically saying is show me how many rows meet these criterias. So show me rating and how many rows match that criteria. We're going to see what that means in a second. Now, we have select, we have from, we have order by, all familiar. We've got this guy here, group by. Okay. This is the thing I'm going to say many, many times. And there are things, this is something I will say to you in the comments of your exercises or other queries. Whenever you use an aggregate in the select query, you must use a group by clause in the query that has the names of every row that's not in the aggregate. Okay? So again, whenever you're using an aggregate query, whenever you're using an aggregate in a query, you must have a group by clause in that query that lists out the columns that are not in the aggregate. I'm going to show you why. When I do this, I have G, PG, PG13, R, and NC17. And what this is telling me is in this table, 178 films are G, 194 films are PG, 223 films are PG13. So what it's saying is every rating that has everything that's a different rating, I'll have the count of that. If I got rid of this aggregate, this group by, oh, sorry, I put it there. Double dash and a space comments it out. So when I comment something out, when I run it, that no longer registers anymore. So when I run this now, oh, they changed it. Okay, so this is a surprise. So every couple months they patch MySQL, which is what this is. And up until this version, if I ran this, it would run fine. It would just see what you'd see is G and the total number of rows that are there, period. So now you get this wonderful error. Nice. In an aggregate query that are grouped by, yeah, that's beautiful. So now you get an error, so it's not going to work anymore. So it can stop talking about that. Okay, so select rating, count from film. I do this. PG, so I look at the next one. Average. What this is going to do, it's going to get the rating, get all the film lengths of all the films with that rating, and then average it out. There's my group by clause. I have to have it because we're grouping by the rating. I'm not using length because length is in the aggregate. This is not in the aggregate. We're running this. Okay. The last one we're talking about is max and min. That's what it sounds like. Show me the rating. Show me the maximum replacement cost of something in that rating. Show me the minimum replacement cost of something in that rating. Doing the group by stuff. Boom. Okay. So we're going to be talking about aggregates and aggregate functions a lot in the coming weeks. I just hit it here at the beginning because there's a natural progression as you watch the evolution of a query and how you go from this simple query here to like, all these not so simple queries here. Right? Okay, now, it is 10:05. We got 25 minutes left, and I still need to talk about how to reverse engineer a website because that's pretty critical. So I'm going to talk about really, really quick how the SQL engine and why I call it an engine processes a query. Okay. So the reason I call this a SQL engine is because when you have MySQL running on your computer, it's constantly running. It is now something that runs in the background all the time. It's not like if I'm running Minecraft here, Minecraft isn't currently running on my computer. It's off. It's not active. As long as MySQL is installed on this computer, it's running. Which means at any point in time, anyone who can access this computer can access the data in the tables on this computer from anywhere else. And that's how applications work, right? The database sits here, it's always running, come get the data and go, come get the data. It's like a 7-Eleven. Come in and get the stuff and go, right? So that's rule number two. So rule number one is SQL is always running. You can come get the data whenever you want. Rule number two is you cannot manipulate or view data that is on the hard drive. So your data, all of your stuff is stored on the hard drive. It just sits there. It is locked down. You cannot look at it there. It's just there. In order to see what's there, you have to take it off the hard drive and bring it into active memory, otherwise known as RAM. Okay. It's like if you've got a book on the bookshelf. You cannot read the book while it's in the bookshelf. It's jammed in between other books. The only way to read that book is to take it off the bookshelf and bring it to the table and open it and read it. Right? All right. So when I run a query, I'm just going to go to this simple one right here. It's going to go to this one here, right? Yeah, I'll just do it. Yeah, I'll use this one. This one's fine. Okay. So when we run this query, the engine has to take the data off the hard drive, bring it into active memory, and manipulate it in such a way it responds to so it gives you these results, right? So now, of these 4 statements, which do you think is the first one that runs?
Select.
No. Select is actually the third one that runs.
Is it from?
From. So here's how it works. I send this query to the engine. Select store ID, concatenate last name, first name, ask customer from a customer, where last name equals Miller, order by this, right? The first thing it does, it converts that to machine language. Your computer doesn't understand that. That's you. There's a universal translator that turns that to machine language. So what happens is now it says from customer. So the engine goes, okay, we need the data from the customer table. So it goes and grabs everything in the customer table and brings it into active memory. So that table is now in RAM. Okay. Now, I'm going to sidebar for a second here because this is a good time to bring this up. When we start talking about design databases, it is very important for you to know how much space that table takes up. And you know that by the data types and rows of data, right? Because if you have 16 gigs, who has it? Let's just, for sake of argument, no one has 16 gigs on anything anymore. Let's say you've got 16 gigs of RAM on your computer, right? But your table is 64 gigs of data. You cannot pull that table into your hard drive, onto your RAM. You'll have failures, right? So you need to make sure when you're designing databases that you are doing it in such a way that the size of your tables is highly managed. We're going to talk about that much later, but that's just kind of a preview of things to come. So this query, the engine goes, go get me the customer table. So it goes there and takes the customer table off the hard drive and plops it into the hard drive, into the RAM. The next one that runs is the where clause, right? So what it says is, okay, look at that last name table and get rid of anything that's not Miller. And that's what happens. It goes from customer, where last name equals Miller. And then it gets this part. And then just get me the columns that they want. And then it does the order by. Okay. So it goes 1, 2, 3, 4. I think there's a question on your quiz this week that says, when does this run? When does select run? The answer I think they give, they say is 4th, right? Because that would mean it's coming after the order by. It actually happens before the order by. Just answer 4th, so you get the right answer. But it actually happens before the order by. Because really, in all honesty, this kind of happens by default when it's pulled off of the table, but they just touch it up. Okay. So that's with the engine. So with the engine, this goes first, this goes second, this goes third, then this goes fourth. With this is an interesting one here, right? So when this runs first, which means it grabs this first, then does that, then does that, then does that, right? And then it pulls that. So this is alive in active RAM first, and then it gets this, and then does this, and then does that, and does that. All right. That's why nested queries, whereas you can do them, and a lot of times they're a good idea, you can nest down pretty far. You can have a bunch of nested queries because you can have a nested query in here. You can have a nested query in the from clause. You can have a nested query in the select clause. You can have a nested query in the order by clause. There's all sorts of weird with nested queries. But what happens is if you use too many, one of two things will happen. Your response time will drastically slow down because now instead of running one query, you're running like 7. Or there is, and I don't know what the limit is for MySQL. The limit for T-SQL and Microsoft SQL Server was 12. You can only have 12 nested queries in one query because they don't want anything more than that. It gets too much. So, fun fact, maybe use it on Jeopardy. No problem. No need anywhere else. Okay. So, any questions on the queries and the syntax and the T-SQL we've talked about tonight, or the whole thing about how a query runs? You just need to know the one thing about which runs and that select goes forth. Other than that, there's no questions on the quiz. But did there any questions, Ryan? Do you have any questions on anything we talk about with these queries? Channel the entire class. Do you think anyone has any questions? I'm just kidding.
I think I'm good.
Okay. Okay, so then I'm going to diverge from this. I'm going to talk about the reverse engineer website. And I was talking about this a little bit last week. Now the reason why we do this is not to torment you, to make you do a video presentation for me, because I don't really worry about that stuff. The reason why we require the reason why this assignment is like this, and I said this last week in the video. In order to have an online course, there is an accreditation process that we go through. The way accreditation works is we need to prove that the people who say they're taking the course are the ones that are actually doing the work. And the way we do that is we have them on video. And it used to be we'd have them on video taking quizzes. And back 5 or 6 or 7 years ago, we used Proctorio, and you guys would have to take 3 quizzes on Proctorio. And if you've never used Proctorio before, Proctorio is this Sploat spy malware thing. They force you to install on your computer, and when you run it, it links you up with some dude somewhere in the country who is just going to watch you on your camera while you take your quiz, which to me is just a little weird and a little creepy. I'll be honest. So instead of that, what we got the ability to do is, instead of having to have you do a Proctorio exam, you can instead in week 2 do a reverse engineer of a website where you do a quick video on camera of 2 to 3 minutes, and you explain to me the website in the way I'm going to explain it to you now. Okay. If you do not do this on week 6, you have to take the Proctorio exam. So I highly, highly recommend doing this. Now, all this is you pick a website, whatever website you want to use. I don't care. Make it something pretty simple. Don't pull up a family search. Don't try to explain the database behind family search. Your head will explode. It's not worth it. It's not cool. Funny story, 3 semesters ago, one of the students in the class was actually a database engineer on family search. So he actually knew how the database was set up, which was really cool. I thought it was really cool because one of these days I want to see that database. So your job is to go find a website, pick a page in that website, and explain to me how you think the back end looks. Now, Do I want anything super specific? The whole purpose of this is just to see how much you know about databases. Do you understand tables and relationship between tables and how the data flows? If you don't, guess. It's totally cool. You know table. At this point in time, everyone here should know because you were in CIT 111. You know what a table is. You should know what a table is. You should be able to say, hey, this table here has these columns, stuff like that. You know, there is no wrong answer. There is no wrong way to do it. The only wrong way to do this is to not do it. And not do a video. That's it. I've had people who submitted a paper, which does not meet the criteria of the assignment. Need a quick video. I don't care that I mean, you could do this and then, you know, you can have, what do I want to do here? You can say, hi, my name is Don. I'm this, and then change to this. Right? And all of a sudden you're an avatar. I don't see your face anymore. That's totally fine. I don't care. I just need to see your face for the first few minutes, and then you can be an avatar dog. I just did this because I think this is fun to do. It doesn't make any sense. Look, I can be a cow now too. Look, I'm a cow. I'm a cow in front of the Salt Lake City Temple. You don't see that every day. Ryan, this is all for you, man. All
I
right, let me take
appreciate
this.
it.
Yeah, no problem. Yeah. See, I actually built this in Minecraft. That is a picture, a screenshot of something I built. Because I did
That's
a
legit.
yeah, I did a Minecraft server for my young men and young women in my ward. And before I let them have it, I built this out, and I had like kind of Salt Lake City in Minecraft world, which was kind of fun. Okay, so we're done playing with this. All right, so here's the thing. So you look here, and we'll pull up Disney Lorcana because this is something I'm learning about right now. So you'll say, okay, here's the website. So hi, my name is Don. I'm in CIT 225 under Professor Stevick. And I'm here doing a reverse engineering of the TCG Player website page on Lorcana, which is a Disney card game. So I think there's going to be a table that talks about the different kinds of products, because here we've got what's called a booster box and starter deck. So there's probably something that delimitates that there's probably a table that's like type, and then there'll be a table that in the table we'll call it, and then we'll have a table called product. And then in the product is probably where there's probably a name column and probably a price column. And it looks like here that there might be like a listings price and then a market price, so we know what the differences are. There's probably some sort of description in there that tells you what it is. And then, okay, so down here, obviously there's individual cards, so there's probably a different set of tables. For the cards, there's probably a card table that has the name and the price in there. There's probably a table that tells you what set it comes from, so there's probably a set table. And then there's probably an addition table, so that's there. And then obviously, since this is a sale website, there's probably a table called customers of people who are going to buy, and then probably a table called orders that shows what customers bought what product. And there's probably some sort of shipping table that tells how to ship to, and then the customer table will have like the person's name, their address and phone number and email and other contact information. And then the card table will have the card name, the card number, the price of the card, the condition of the card, and then the set table will have the name of the set, when it came out, and some other stuff. And that would be it. That's all you have to do. So not super hard. It's just basically giving, and when I watch this, it's just giving me a basic idea of how much you understand table structure. That's it. So that's that. So it is 10:21, and we're 9 minutes from the end of the thing, the night. If there are no questions, we'll go ahead and call it a night, and we'll be done, and I'll post this up on the good old announcements and call it a night. Do you have any questions, Ryan?
I think I'm okay.
Excellent. Well, thank you for attending. Those of you
Thank
who are
you.
watching at home, thank you for watching. Those of you who didn't watch, you're going to struggle in this assignment, and really, whose fault is it but your own? I can only do so much for you, and I can only suggest you watch these so much. And I feel safe saying this because you'll never know I said it because you're not watching. And Ryan and I will Ryan will get an A in the class, and you may not do so good because you never saw this. So there you go. Those who are watching, you will join Ryan with A's, and everyone who's not watching, you don't even know what I look like. I might be a talking cow for all you know. All right, Ryan, you have a great night. I'll see you next week. Everyone else, see you next week.
Have a good one.
You too. Bye-bye.